Okay, kids, we're going to start a new unit here on polynomials and factoring, and we're going to start by adding and subtracting polynomials. Okay, so a single term is called a monomial. Okay, and a monomial, it's better to say what a monomial isn't. A monomial never has an exponent that's a fraction, and it never has a negative exponent, and you'll never find a variable under a divided sign. Okay, so if you're going to have a monomial, it's just got to be, it can't have any of those three things. So when I look down at these, a monomial is a term that doesn't have any plus or minus signs between it and don't have a fractional, negative, or have a variable under a divided sign. Okay, so these four things here that I've underlined are monomials because they don't have any of this stuff and they don't have any plus or minus signs splitting up the terms. Okay, so the sum or difference of two or more monomials is called a polynomial. Okay, and specifically, if I've got the sum or difference of exactly two monomials, it's called a binomial. So it's got a special name that comes with it. So the binomials here are going to have two monomials that are added or subtracted. So this is a binomial. This is a binomial. So this xy is considered a monomial because it has no plus or minus signs separating it. So this is one term. There's another term. So 1 plus 1 gives me 2. It's a binomial. Here, this is not a binomial. This is a monomial because it doesn't have any plus or minus signs separating any of the parts. And down here also, last one, that is also a binomial. Okay, the sum or difference of three monomials is called, all the rocket scientists out there, a trinomial. Okay, so let's just scroll down here a bit. So just like the binomials, that means two terms that are added or subtracted. Here I need three terms that are added or subtracted. So I need to see three terms separated by a plus or minus sign. So this is a trinomial. This doesn't have any plus or minus signs, so that's just a monomial. This is a trinomial. And again, no plus or minus signs here, so this is just a monomial. Okay? So let's take a look at how polynomials add and subtract, how we add and subtract polynomials. Okay, so here we're going to use some tiles. And it says use tile representation to model the sum or difference of each set of polynomials. Combine the like terms and write the resulting polynomial. Okay, so here our x squareds are our big boxes. So there's 2x squared. And we've got our rectangles represent our x's. So that's 3x. And our little boxes represent our single digits. Okay, so here I've got two x squareds. Each big box is an x squared. Each rectangle is an x, so 3x's. And then each little box is a unit. Okay, so I'm going to add that to 1x squared and then minus 5x's. So I'm going to have 5 rectangles here. But I'm going to subtract them. So the way that I showed that I subtract them is by shading them in. So here we go. So it's minus 5x squared. So every one that's shaded is going to cancel out every one that's not shaded. And then also I'm going to have 5 single units. But they were all minus, so I'm going to shade those in as well. Okay? So the idea here is that I can only add and subtract big boxes with big boxes, rectangles with rectangles, and units with units. So it looks like when I can add these up. 1, 2, 3. It's going to give me 3x squared. Okay, and here I've got 3x's, but I've also got minus 5x's over here. So 3 of these are going to subtract another 3 of those is going to leave me with minus 2x. And last but not least, I'm going to have plus 2 units are going to subtracted by another minus 2 units, or sorry, added to minus 2 units is going to give me, break me even, and I'm left with minus 3. So when I look at the algebra up here, I only want to add up terms that are like terms. So I look at my squareds, I add those two up, 2 plus 1 here. When I look at my x's, I put those together. 3x minus 5x gives me 2x. And I look at my units, plus 2 minus 5 gives me minus 3. Okay, I'm going to leave 5 for you as an exercise to do. Okay, so let's just take a look at a couple of these things. This is a good illustration of how you only can add or subtract like units. Okay, so you have to make sure that the variables match as well as the exponent for each variable, and then you can add the constants appropriately. So here I'm adding everything up. So because these are like terms, I can say 4 plus 6 gives me 10 x squared y squared. Here I've got like terms again, x, y, x, y. So 5 plus 8 is going to give me plus 13 xy. And here, let's make sure they're like terms, x, y squared, and xy squared. So minus 3 plus 3 gives me 0 xy squared, or just 0. Okay? But the idea here is that if even one of these exponents is different with the variable, or one of the variables is different, I couldn't add them up because they wouldn't be like terms. Okay, so let's take a look at number 7. And you have to make sure that you pay attention to what's going on here a little bit better. All of my like terms are lined up nice here. So I've got m squareds and m squareds there, m's and constants and constants. But we have to really make sure that we pay attention to what we're doing, what our operation is between the two lines. So here, I'm going to go 11 minus 5 gives me 6m squared. Okay, but here I'm also, I really have to make sure I put these two signs together. 2 minus minus 6 makes a plus 6. So 2 plus 6 gives me plus 8m. And here, negative 11, 2 minus signs gives me a plus. Plus 17 is going to give me plus 6. Okay, minus 11 plus 17 gives me plus 6. Okay, so it's like I have to deal with the distributive property there. So I'm going to leave 8 and 9 for you as exercises here. Okay, so fill those out. And we'll go on to the next problem here. When you do 8 and 9, just make sure that this is the one that you got to be careful of, right? You have to make sure that you distribute that minus sign to each term before you actually go and add things up. Okay, so let's look at 10 here now. 10 is a little bit of a problem-solving question. Okay, so it says the measures of two sides of a triangle are given. P is the perimeter, and it's saying find the measure of the third side. So all we're trying to do is find the distance all the way around the triangle. Okay, and they've given us the distance rather than it being constants. It's saying 2 plus 3 plus 4 or something like that. It's giving me the distance in terms of x. Okay, in terms of a polynomial, right? So if P is the total perimeter, my perimeter is going to equal, if this side is equal to side 1, and this is side 2, and this over here is side 3, my perimeter is just going to be the sum of all those sides. Side 1 plus side 2 plus side 3. Okay, so let's fill in our pieces here. So this is the total perimeter, right? So that's going to go on this side of my equation. So 4x squared plus 5x plus 5 is going to equal, and now let's look. Side 1 is equal to 2x squared plus 3x plus 6, okay, plus, so this is side 1, plus x squared plus 3x minus 5, and then plus the side that we're looking for is side 3. So what we want to do is isolate this variable so we can collect like terms on this side to make life a little easier for ourselves. Okay, it's just a little organization here is what you got to be careful of. So here I'm going to leave this 4x squared plus 5x plus 5 is equal to, and here 2x squared plus 1x squared is going to give me 3x squared. 3x plus 3x is plus 6x, and plus 6 minus 5 gives me plus 1, plus my s cubed, or my s3, my side 3. Okay, so let's go and finish it off and isolate. I want to isolate for this variable, so I'm going to subtract these terms from both sides to make them 0 on this side and bring them to the other side. So minus 3x I want to put in here, minus 6x minus 1. Okay, and I'm going to do the same to this side of the equation so that I keep my equation balanced. So minus 3x squared minus 6x minus 1. So on this side, the 3x squareds cancel out. Okay, 3 minus 3x squared gives me 0x squared. Let's draw a little line here. Okay, the plus 6 minus 6, like I wanted it to, is going to give me 0, and the plus 1 minus 1 is 0. So all I'm left with on that side is the third side. Okay, and then over here, I've got all my terms lined up properly, so all my like terms are there. So 4x squared minus 3x squared is just x squared. 5x minus 6x gives me minus x, and then 5 minus 1 gives me plus 4. Okay, so that's my third side. X squared minus x plus 4. Okay, and I guess if you wanted to, you could go ahead and check. We know that these two pieces were equal to 3x, let's put check up here, check. Okay, 3x squared plus 6x plus 1. Okay, that was side 1 plus side 2, side 1 plus side 2 gave me this in here, right? Okay, so if I add that to my third side, I should end up with what my perimeter is. Okay, so let's add on here x squared minus x plus 4. And what am I left with? 3x plus x squared gives me, I like it so far, 4x squared. 6x minus x gives me plus 5x. Again, so far so good. And finally, 1 plus 4 gives me plus 5. And that finishes it off. Okay, and that's it. Adding and subtracting polynomials. Just make sure that you're always adding and subtracting like terms. Ciao for now.